Okay, so this is our program as we have redesigned it, and I apologize if you don't have a copy of this, but this just really came about yesterday that we actually got this to this point. And I got a bunch of emails last night from the associate dean, and it was disturbing to me because we have given up in engineering technology this course right here, which was in engineering technology. This is a 1 hour course, but now it's a 3 hour course. So we gave up 2 hours there. And down here, we gave up a course that we basically put in, which is this right here, which is a 1 hour course, which is preparing you for the co-op. So we've given up 3 hours there. We come down here at the end and we gave up 1 hour there, so that's 4 hours. And then I got hit this morning with the thought that we would have to give up another 3 hours based on the fact that if we have a mandatory co-op, there's a mandatory 3 hours of co-op that is put into your program. And we're limited to 128. We cannot go past 128. So you take something out, you put something, if you put something in, you have to take something out. Now, that being said, those of you who were opting to go into the mechanical program, they basically told us that we had to have 15 hours, and I said, I'm not going to go any further than 3 courses. So they said we have to discontinue that concentration, so I did. But I put them back in as electives, so you can take the 3 courses electives. So the mechatronics and the 2 concentrations are gone as official concentrations, but you can effectively have either of those by using these electives. Okay, so you can get what you desire. It's just basically the word mechatronics or the word mechanical concentration won't be on your diploma. Now, if you want that badly, I can put it back in, but I have to take a course out. The course I would take out would be embedded systems. This C programming and embedded systems course, you learn stuff in them, but the way that they're being taught right now is not good. But we can correct that, and we can have these as really good courses. But that being said, how badly you need an embedded systems course is a question. So these 2 courses could be combined, is what I'm saying. And that would give us another 4 hours. If you want to have your concentration, I can combine these 2, give you the extra 4 hours there, and then you can have 4 electives, and I can come down here and give you a 4th mechanical elective. Okay, if you want the mechanical concentration, I can put it back in. It's not too late to put it back in, but 3 courses is what I settled with originally, and that's what I did. And a 4th course would really, it tips the scales more into the mechanical side. If that's what you want, you're the boss. I'll do it. But I took it out because, boy, it's hot in here. Do you feel it's warm? It's extremely warm. Sorry about that. So anyway, the word is, I changed it yesterday, it's being discussed, but this is going to be the way it's going to be unless somebody comes along and changes it. But the associate dean wants to change it again and take out another course and add in 3 hours of mandatory co-op. Now, if you do the co-op as a volunteer, not as a mandatory thing, you can do it. You just don't get credit for those 3 hours. So we basically cheat you out of 3 hours, even though I don't know if you pay for them or not. But if you have a part-time job, that can count as a co-op. I'm very much in favor of part-time jobs. If you're interested in taking a part-time someplace, I'll give you some names. There's people out there that want your services. You may not believe it, but you are qualified already to take on a part-time job in an industrial environment here in Little While. Okay, they need your help. Just this one course right there will get you a job. The AutoCAD course, believe it or not, it'll get you a job. Okay, that and this and this will get you a job. These 3 courses will get you a job. These 4 will definitely get you a job. These 5 will help. This one down here will help. Okay? Those are the ones that will get you a job. This one especially right away. Then this one will help you go further. And this one over here will help you go further. And then some of these electives down here will help you go further. But that's where you build your careers when you get into your electives. So the mechanical courses that are listed here, there's 3 of them, and I could list a 4th one if you want. I could list another one. I don't have to stop at 3, but these are the 3 that are the 3 that are recommended. These are the 3 that were part of your concentration. Okay? But I could put a 4th one in there if you want to. So anyway, now in this program, you can take EET 2410 as 2410, and then you can take the follow-up course as 4550, and there's 4550. Or you can take them as, here you go, you can take MIME 4440 or EECS 4220, which is equivalent to both 2410 and 4550. We cover the whole book in 4550, or and we cover the whole book in these 2 courses. And you can do that. Either I offer you either of these 2 courses. Either one of these cover those 2 courses. So you can say, do you want a 2 for 1? Yeah, there you go. This course here, you could be covered with this course here, and one of the electives could be covered by either one of these 2 courses. You just go through it faster. I teach the same course. Either this course and these 2 courses are taught in the spring. Okay? Same course. Taught in the same room at the same time. We go through all 21 chapters of the book. It takes into account that you've probably done something like what you're going to be doing in the next month of this course, which is to kind of set you up so that you will be able to go through this course a lot quicker. The guy that teaches this course right now for us at 2410 says that basically the EET students know what's going on and they get through it very quickly because they've taken what we're going to be doing in the next month in this course. So I set you up for success in this course by what we're going to be doing next month in this course. Okay? So anyway, here's a wise guy, wise man. He's got his bottle of water or can of water and ready to go. Anyway, yes, sir.
So are they looking to make the co-op mandatory or still voluntary, but you're forced to take the co-op class anyways?
That's the question that I'm asking you. That's the basic question I'm asking you right now. Now, I've gone halfway. In other words, when we joined electrical engineering, and we haven't officially joined electrical engineering yet, but they dissolved the program that we're in. So we are either homeless, visiting the homeless shelters every night, or we go to EECS, and we're going to EECS. They just haven't approved it yet by the Board of Trustees. So I'm not officially yet a faculty member of EECS, but it's just one of those things where it's just a foregone conclusion that we'll be part of EECS. That's why we did this, which is a 3-hour course instead of a 1-hour course. You're taking a 1-hour course, right? You took a 1-hour course at ENGT 1000. If you didn't already have a course that's like where's the bathrooms, where's the library, where are the, you know what I'm saying, that course. If you didn't take that course, if you've taken that already someplace else, we give you credit for it. Very quickly you can figure that one out. But what we talked about in that version of it when I was an undergraduate was, why are the drinking laws at 21 when everybody gets served at 18? All the bars in Champaign County, why are all the bars, why did they give you why do they serve so that you could get arrested while the drinking age is 21? And it was an endless conversation, and people would sit around and talk about it like, that isn't right, whatever, I don't care. But anyway, that was what my version of that course was. It was talking about the drinking laws in that county. Sounds like a worthless course, but it was interesting. But anyway, that's what I remembered from it. But anyway, that course now is a 3-hour course because it's got some programming in it. So that's what they're going to have starting in the fall of next year, of 26. So that would be what the cohort would a year behind you would be taking would be that course right there, because the EET or the ENGT 1000 course is going away. Or it may not go away right then, but it's going to go away. So anyway, we're going to jump over to this course, but that cost us 2 hours, and this cost us 1 hour, so that's 3 hours. So we had to do something down here to get rid of something. So we got rid of the professional development course down here. If you want to look what we did, we took away the professional development course down here. Anyway, so we still have 3 electives: tech elective, tech elective, tech elective. So you still have 3 open slots. Is there any question about what this program is about? Now, if you go to co-op, they're supposed to have 2 cohorts, an A and a B, and one starts immediately on the co-op, and the other starts into the courses, and then you flip flop. And honestly, I don't see how we can do that because we're still too small. And they said, well, you can do that, you can do that, you can do that, and I don't see how we can. The only course in this program that is only offered that's only offered on a one shot every year basis is this course right here. And it's the worst course in the curriculum. If you want to know, this course right here is the follow-up to our course. Okay, so right here, and then this course comes along and takes over where this course ends, and then this course begins. The same theory, the same stuff, and it's all theory. Okay. And it's the hardest course in the program. It is the one course, if you were to ask people, the most dreaded course in the program, and there it is right there, okay? You kind of do the same thing here as you do here, as you do here. So you do the same stuff here as you do here, as you do here. This is easier than this. This is kind of this, but not as much. It's Laplace, and using Laplace to solve electrical circuits is what this course is. This has a little bit of Laplace in it, but not a lot. This has a lot of Laplace, but it doesn't specifically solve electrical circuits. And once you've done this, some people take this before this, some people take this before this, but those are the 2 courses that kind of are the hardest courses, but I don't care which one you take first. You can take this one before this one or this one before this one. It doesn't really matter to me. Of the 3, this is the hardest of the 3. Okay? Now, which one in what order you take them, I don't really care. Which makes it almost impossible to have an A and a B cohort. Now, this course is offered every semester. This course is offered every semester. This is only offered once a year in the spring. So I don't care how you do this, but you got to be here in the spring to take this course. It's at 8 o'clock in the morning. It's the course that I teach on Monday and Wednesday. I teach your course Tuesday and Thursday at 8 o'clock. And it's been a interesting ride. 4 days at 8 o'clock is a little much for this guy. But anyway, that's where I'm at. So my question to you is, any discussion on the idea of, do you want to make a mandatory co-op or not? I already destroyed your concentrations. Now, do you want to really destroy it, or do you want to keep it as is, as much as possible, or do you want to go the full boat and say, let's make it a mandatory co-op? And I'm not saying just destroying it. I'm just saying I had to take 3 hours out already. Everybody see that? I had to take 4 hours out already. Do you want to take another 3 hours out, or do you want to say we stop at 4 hours and we basically, what you signed up for now is 4 hours lighter. Do you want to take another 3 hours out, or just say the heck with it? Yes, sir.
So this question will change our maps, or we lock room ones and spring students.
You're going to, the answer is I don't know. I don't know whether they'll give you the mechatronics or the mechanical option because you signed up for it on your diploma. I don't know. It's a good question. I don't have an answer for you. They might. It's like, for me, I got into the honors program, and then after being in it for a year, I said, I don't want to do this anymore. I just want to be a regular guy. So I didn't take any more honors courses, but they gave me, at the time they didn't check it. Now they check it, but they bumped my, I got, I actually made the honors. I got honors, but they made it high honors because I'd been an honor student. So my diploma actually is a misnomer. It says high honors. I only got honors. I only got 4 point. It was we're on a 5 point. I was on a 5 point scale instead of a 4 point scale. 5.3 to 4.3 to 4.5 was honors. 4.5 to 4.5 to 4.75 was high honors. 4.75 to 5 was a highest honors. I got honors. I was an honors student. I was not a high honors student. But anyway, they put high honors on my. I was embarrassing. I didn't get high honors. I was just. By the way, is being an A student the best thing you can do for yourself? No. No. B students get the best jobs and they get hired the first and they usually make more money. Don't be put off by that statement, but it's true. Okay? So having a straight A average is good. It can be very good for you, but on the other hand, it's not going to guarantee you a higher job or a better job. It's one of those things where it's a mixture. You have to have a life, you have to have outside interests, you have to have friends, you have to have, and you have to have, and you have to have, and usually that lands you in the A minus B category. Okay? Not telling you that you can't get A's, and I'm saying please try to get A's, but it's not the kiss of death if you graduate here with a B average. 3.95, 4.25 is, or excuse me, 4.0 is the highest you can get here. 3.0 is a B average. So 3.2, 3.1, 2.9 is not the kiss of death. You can get a job and you can get a good job. Okay? Please do not be discouraged by the fact that you might not get straight A's. But with great inflation, that may not be the case. I don't know. You say, is there great inflation? I don't know if there's great inflation here. There is in some cases because you don't have enough people to grade A, B, C, D. If you have enough people to grade A, B, C, D, there will not be great inflation, but that's not always the case. I went to my granddaughter's graduation last year at another university, and the number of people that walked across the stage with perfect 4.0 averages was phenomenal. And I'm not saying that they didn't all earn those degrees, but like person after person after person, they all graduated, but 3 out of 4 graduated with a high honors or a perfect grade. This is, if you've ever seen, what is it? Garrison Keillor and the Prairie Home Companion. Did anybody ever hear that guy? Everybody hear the name of that guy? Prairie Home Companion, Garrison Keillor. He was on for a long time on public radio on Saturday night, and he broadcast from a little town in, supposedly it's a fictional town, but it's a little town in Minnesota, and where all the children are above average. And you shake your head. It's like, everybody knows that that's a misnomer because the average is whatever it is. So where all the children are above average. Anyway, I don't know. I want you to get through. I want you to be successful. I want you to know something when you get through. Did you realize that this curriculum actually does teach you something? That you actually improve your knowledge base when you get through this curriculum? Have you figured that out yet? You do. It's one of those that defy the modern whatever it is that says, higher education isn't worth much. This one actually is, because it actually teaches you a skill. Maybe you don't believe that. Maybe you're saying, sure, Ted, tell us another Western. No, it actually does teach you a bunch of skills, and these skills are embedded in these courses. Anyway, I'm asking you a question. Any comments? If I ask you to vote, which way would you vote? Would you say you want the mandatory co-op or you want to stay as is, keep the 3 hours, And I'm of the opinion, yeah, I'm swimming against a strong stream because they're wanting everybody to go into the mandatory co-op. Now you can take the co-op. You can go over there and register and they'll give you the option, or you can take the co-op and get credit for your part-time work in the co-op office, which is a good way to go if you want to, but to make it a mandatory and kill off those other 3 hours would mean I would have to take these two courses, put them together, and make a combined course, and I just can't do that. I can do it with a committee to say that's what we want to do, but I just can't by myself commit to doing that. Now, are these two courses worth very much? The way they're being taught right now, I would say this course isn't worth much. This could be one of your best courses, but the way it's being taught right now is not we're not in a good situation with the course. This course right here could be a really good course for you, or not. But the course that we had before this in this slot was a reprise of this course right here. So you did this course and then you did it again as this course. So when we put the two curriculums together, the 2-year program and the 4-year program. So in other words, we had a program just like Owens did. And it was a 2-year program, graduated people with an associate degree in engineering, electrical engineering technology. Okay? Matter of fact, we were there before Owens was there. If everybody says, well, Owens has been around forever. We were there before Owens was there. The University of Toledo had an EET program before Owens even existed. So we had this first 2 years. Then they came along and they created a 3rd and 4th year, and then they put the two together after a while. They didn't do it right away, but after a while they put them together. And what they did was they had a 2-year program and they had a 4-year program, and this course and this course were the same for the most part. I eliminated that. I said, well, we really do need to have something other than this course reprised, so I made it different. And we made this course interesting course as well. But right now it's not in a good place. But that doesn't mean that we shouldn't have this as a course. So anybody have any thoughts? If I took a hand, yes. Not. Okay, thank you. Anybody wanted to have a mandatory co-op? No. Are you disappointed that we took out the concentrations a little bit? I defended the idea of keeping the material. Okay, you can get the material. You just won't say it on your diploma. This course right here is a robotics course. I hate to say it's better than this robotics course, but you learn about the same thing, kind of. This course is a canned course from FANUC, and it is not good. The teacher that teaches it, she's as good teacher as you're going to get, but she did not expand it beyond what the FANUC people dictated to do. And as a result, it's never really flown, and it never attracted people to taking the second course. The second course never ran. Although we keep them on the books, it never ran. So we kind of incorporated both of these courses into this course right here. You see, what's the only robotics course that really is worth its weight in salt in University of Toledo? It's right there. As I teach it, and I make them learn how to do that. The robotics, I make them learn how to tie it to a vision system and to a PLC. So at the end of this course, you have a PLC, a robot, and a vision system all tied together, all doing something. It's questionable what that something is, but it's doing something. Anyway. So, all that said, I don't know where the robotics stuff is going. I just know that this course, it will still be taught. This course may run. I don't discourage people from taking it. But realize going in that it's a FANUC canned course that is taught at high school level and taught at the 2-year college level. Okay? But you might learn something from it, and if you want to, you can take it. You can also take this one if you want to. They're both in the fall. It's your choice. And again, those are the only two options you really have. But this one and this one will get you some robotics. Anyway, that's enough on that. Now, just warming up today, right? Just getting started. So, the other thing I want to talk to you about is course, what we're going to be doing, the conduit project. Okay. So this I want you to do, and I want you to have it handed in by next Monday or Tuesday. Excuse me, next Tuesday. So this is your quiz or your project for the next week. So this is a project of basically looking at how to build a set of conduit to get your wiring in. Now, this is I told you before, this is you can make a bunch of choices on this thing, and I want you to understand that you have a lot of variability in this. Okay, so this is the NEC excerpts. This is where you find all this stuff. So you have to ask the question, how do you go about this? Well, you have to basically settle in on an idea of how you're going to build your manufacturing facility and what you're going to use for wire. And then you start, whether you're going to do it 230 volt or 460 volt. You have to do all that stuff. You're going to have to decide that yourself. You're going to have to declare all those variables, how you want to deal with those. Once you've done that, then you say, okay, now how am I going to structure this? Well, each motor, and I'll get a little thing up here so you can see, each motor requires you to have a so there's each motor going to it has 3 wires. So you've got over here, you've got a motor control center, okay? Commonly called MCC, motor control center, okay? And over here, you've got a motor, all right? You've got a motor. It's got 3 wires coming out of it. And there's a ground, okay? Now, you probably also have a start-stop station, okay? Start and stop. Which requires 3 wires. So there's 3 number 14 AWG, or if you go a long distance, it could be 3 number 12 long distance, 3 number 12 AWG wires to cover these 3 to cover this start-stop station. So for each motor, you have a start-stop station, and that start station goes back to the circuit over here, and then you go all this in a conduit, these 3 wires, that wire, these three wires in a conduit going back to some location. So basically, these start picking up, like you have a conduit. Here's your motor. Here's a conduit, and at some point in time, then you go to a pull station, and all these things come into some kind of a pull station, pull box. Okay, you might have 20 of these going into a pull box, and then you have the pull box going to another pull box, and then you have these pull boxes going back to the MCC, okay? Or you can go blah, blah, blah like that, but you have to make a drawing. You have to show how this is all going to be done. And this might have motors on it like this. Up here. All these are conduits. You have to size all those conduits. So what you do is you do a little circle around this and say a 3/4 inch conduit with, and then you list all the wires. 5 number 8 AWG wires, 4 number 12 AWG wires, blah, blah, blah. And that's what you do. Okay? List them all. There's a bunch. This is not a 5-minute job, but it's a job that you can do. And in so doing, what you're actually doing is what? You're showing how the wiring goes back to the main terminal. But you have to read through in order to figure that out. So you got to pick a voltage, either 230 three-phase or 460 volt three-phase. That's the first thing you got to do. Then you got to pick a wiring, like what type of wire do you want to use? THHN, XHHW, or other. And you pick a wiring type. And then you use that wiring type and you go back all the way back. Okay? Now you can use XL to do this. XLS. It will help you because then you can sum all these things up and kind of keep track of them in a orderly way. Please do not put them all to one pull box. Okay? So don't just have all going into one box and then going back. Have multiple pull boxes that go back and then from there you go back. So they don't all go just to one pull box and then go one big conduit back. Or you may pick a wireway. I'd rather do a wireway than a conduit. Why is that? A conduit is round and a wireway is flat. It's got a cover on it, but it's flat. Next Tuesday, you got a week on this one. Okay. You're gonna poke around and all the clues are there. All the parts and pieces are there. They're just all over the place. Okay. What's the size of the ground wire? Oh, it's not as big as the three motor wires, but it's still there. You have to put it in there. Okay. Where do you size that? Well, it's in here. It tells you the size of the ground wire for each motor size. It tells you. Okay. You have to run a ground wire for every one of them. Next, everybody understand this? Everybody got this idea down? You basically create a drawing that does that. Okay. Good deal. Are you looking forward to that? Yeah. It's different. This will get you a job, by the way. If you can do this, you can do this all day, every day, if you want to do this. Not that you would want to, but you could. Okay? How many of you want to do this for a living? You want to be more creative, right? You can do this for a living if you want to. You can make good money at it from the contractor side because why? What does the contractor want to do? What is the contractor's job? To make money. And if you can get this done cheaper, faster than the other guy, you win. Okay? When they built the plant in Amarillo, Texas, for Owens Corning, they were building it on a fast pace and they couldn't afford to put all the drawings out ahead of time with all this stuff in it. So they just bid a cost basis. Okay, they bid it at cost basis. It's the only way that any of the various contractors would bid it. You know what the contractors did? Oh, they ran the cost up for sure. Now that's a given. Okay, but here's your ceiling, and here's your cross members that come down from your ceiling to support your roof. What did they do to run the cost up? They went bing, 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 bing. What should they have done? Bing. Do you think people do things like that? Oh, yeah. Okay. Anyway, Beside the point. Those are good stories. The unfortunate part is that they're true. Okay, next. So this may cost you the whole morning. I don't know. This next one is the biggie. It's your project from now till the end of the semester for lab, and it will get you 4 lab grades. Okay, so 4 lab grades, 3 on the one and 1 on the second one. Okay, so this is your project. All right, so this is your the one we've been talking about and all that good stuff. Well, I don't see it there. I got to go back to the this guy. Okay, now this is not what I want. I want to go back to this. And let's go down here under okay, this is the scan of the linear actuator program. So this is I showed you this the other day in lab, and that's why I showed it to you, because I want you to be able to hang on a minute. Okay, so what you're going to be building is you're going to be building a control for a linear actuator. And I give you, with this scan of this picture, I give you most of the circuitry for this. But at the heart of it is this circuit right here, which is twice done. It's done twice. So this is the timer circuit. So when it hits the limit switch at the end, so when the limit switch, there's a little low limit switch here, it hits the end of this traveling piece. Here's my traveling piece. When it hits that, you got 3 prongs coming out, right? Now one is like this. So you basically have a switch position, a common, and another switch position. So when you are hitting it, when it's being hit, this one is connected, or when it's not hit, this one's connected. This would be my normally open. Excuse me, this would be my normally closed position. This would be my normally open position. So when it does not hit, this one is closed. When it is hit, this one is closed. You have to figure out which one of those is which. Okay? So when this hits here, you have 24 volts, and this closes, and you have voltage. Then when it de-energizes, okay, so when it's not hit, this is closed in this circuit. When it's not hit, this is energized. When it hits, this opens. So this goes to 0 volts. So what you have is you have a circuit that had a voltage supply, 24 volts, the resistor, and a capacitor. And then at the end of the cycle, this goes to short, this goes to ground, it goes to 0 volts. What happens? Like that, with an RC time constant, right? It decays, all right? Everybody agree with that? So when this turns off, this starts to decay down to 0. When that happens at 0.7 volts, here's my decay cycle. At 0.7 volts, this switches. It was one way and then it switches the other way. And I'm not going to tell you which way it is, other than the fact that it's on. This is conducting until this is at 24 volts until 0.7 volts, and at that point in time, this point right here goes to 0 volts. Okay. Now, what is this? This is a NPN transistor. Okay. You have some of those in your kits that you were given. If you can't find some, we'll give you some more. But it's an NPN transistor. Now, there's three, if you look at it from above, there's three, this is looking at it from above, you see three wires coming out of it. The E, the B, and the C. The E is the emitter. The B is the base. The C is the collector. This is your emitter. This is your collector. This is your base right there, okay? So looking at it from above, with the flat side to your right, the top wire is the E. That's this one right here. The middle wire is the B. That's this one right here. The bottom wire is the C, the collector, and that's this one right here. So E, B, C. And then you put a diode around it. Why do you put a diode around it? There's already a diode up here. When this closes, this is an inductor. When it opens, it's an inductor. What happens to inductors when you open them? The current doesn't stop flowing immediately. It is like a flywheel, and there's current that has to flow, and it has to backflow. So this is like a backflow of current. So this saves this from blowing up. This is not there for anything except for the fact that when you turn the circuit off, this will fry if you don't put it in there. If you don't believe that, leave it out. It'll work for a couple of times, then it'll stop working. Say, why is my transistor not working? It's fried. Okay, so this saves this from disaster, from catastrophe. That's all this is, right? Eli the Iceman is still real. E-L-I, E equals voltage divided, E equals L di over dt. There it is. You cannot immediately stop the current flowing through an inductive circuit. So it still has to flow backwards, and it flows up like that until that inductor stops flowing, current flow stops flowing. That's how that works, and it works. If you put this in, it works. If you take it out, it doesn't work. Now, this is a circuit that all its job to do is to get this to delay flowing, this delay clicking after this one clicks. In other words, this one clicks, turns off, delay, 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 until there, and then that. Now you say, how long is that delay right there? It's a little more than a tau, but it's RC is this delay, okay? So what do you pick for a resistor? What do you pick for a capacitor? I don't care, but it's got to be about 2 or 3 seconds. Oh, so I got to pick my own. Yeah, sure. Everybody now see why this is an interesting project? Because you have to decide some things. You have to decide how to do this and how to put this together. You have to decide about this, how to get it so that when this turns on, when this hits, this turns off. This has to be turning off, and then it dies, and then you see it die. You put it on an oscilloscope, goes down. Okay? What's the resistor value? I don't care. What's the capacitor value? I don't care. But it's got to be about 2 or 3 seconds. I got to see a delay. Okay? How do I put this together? You got a breadboard? That's why I got you a breadboard. Okay? Any questions about this? And you have to have 2 of these. Then you have to have a seal circuit. Oh my goodness. When it's going one way, it's sealed. When it's going the other way, it's not sealed. And that's what this circuit is about. And that's explaining that right there. The dir is on one way, it's off the other way. So you're going one way, the dir is on. When it's going the other way, it's off. Now you got to do that part, and then you got to come down here, and you got to flip the leads. This is a suggested circuit, but it's not the only way to do it, but this is a suggested way of doing it. You're done. Once you've done that, then we'll talk about the PLC side. The PLC side is not bad. PLC side you'll do in about 20 minutes. Once you've done this, we'll go through the PLC side, and it's not hard, but it's very, 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 very doable. But we'll go through how to do that as well. So you get a chance to do it this way, which is the old school, really hard way, and then you'll get to be able to do it with a modern device, and you'll say, who would ever do it this way? Well, you just did. You did it the old school way before 1970. In 1970, they started buying PLCs in droves because they were through doing this. So 1970, 1975 became the delineating time that people did not want to do this anymore. And they didn't build timers like this. Even then, they had what they called dashpot timers that would actually, it was a pneumatic timer that you would actually set up a little thing, and you'd hear click and then and then click, second click, based on a pneumatic, an air bladder inside. So they did it with air instead of this, but you can do it with this. We don't have a little air bladder, so you can do it with this. I wanted you to do it with this because why? I wanted you to be introduced to diodes being used as switches. Transistors being used as switches. I want you to see that because you can use transistors as switches, and there's a good example of it. Okay. By the way, you'll probably blow up a couple of these. That's why you got a bunch. That's why we got some spares. But I'll help you, okay? I'll be in the lab helping you. How do you mount these, all this stuff? Hammer, nails, drills. How do you put the wires onto these guys? Solder. So it's a little of all of the above. It's just a little piece of a lot of parts and things. And if you need stuff, I'll help you. We'll get stuff built up and we'll have the card over there. And there will be times when you will not like me because of this lab. This is one that will test you beyond. Well, that's a simple lab. That's not a big deal. We don't have to worry about that. All right. Any questions so far? Everybody, you got two of them now, right? No biggie? Who can I partner with that they'll do all the work? That's the next question. Who can I partner with so I don't have to do this and they'll have to do this and we'll do it together? It's up to you. Two at the maximum together. If you do three, I don't want that. I want two or one. If you want to do it by yourself, good. It's excellent. A lot of people do, and that's okay. I don't mind that. Why? Because this is a lonely business. If you figured this out, if you haven't figured this out yet, some of the time you're standing there by yourself at a panel programming something, and you're the only one, and people come up to you and say, "Are you done yet? Are 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 you done yet?" And after a while, you just want to say, "Leave me alone." It's very lonely. It can be a very lonely business, but I know that you're saying, but I'm the only person that can pull your fat out of the fire and make this thing work. I'm the only one. And you are the only one. They aren't standing up there and doing the work. You are. And you're getting frustrated, but you're also going to get credit for it eventually, and you get paid for it. Anyway, believe me when I say you will get frustrated at times in the real world with this kind of work. It doesn't come easy. This circuit will cause you a great deal of consternation. Because I don't tell you everything. I tell you most of it, but I don't tell you every little thing to tie down and every little thing to do. I give you most of it. I suggest, but you got to put it together. Anyway, I give it all to you, but you just got to put all the pieces together. And it's close, but it's not completely done. Okay, now, so I got my answer, and I agree with you on the idea of co-op mandatory. I don't want it either. They're going to push hard, but I'm not going to. No. If you want it, it's there. If you don't want it, if you want to walk into the co-op office and say, find me a job, they'll find you a job. But you can walk out of here and you can look at half a dozen places in Toledo that have ads out for, or I can give you names. I can give you names of people that are interested in hiring you. And most of the people don't ask me, they just find them because they're there. You may not think you can find a job in electrical work, but they're there. And I'm serious that you can find them. And I'll give you half a dozen names. And on my website, I used to have them, but I took them off because I didn't want to disfavor somebody else. But you can find a good job as electrical blah, blah, blah in Toledo, Ohio, and make good money at it. Now, I'm not discounting the next statement. You can work at Home Depot, and they pay well. They're not a bad place to work, but you will find that it will not get you as far in your ultimate goal of a good paying electrical job as if you were to work for an electrical design firm or somebody that programs for PLCs, or a design firm that does this wiring diagram that I just gave you, or some other AutoCAD function, something that has to do with electrical circuits and electrical controls. It can either be power, or it can be controls, or it'd be combinations of jobs like that. And you say, I don't want to program PLCs the rest of my life. You don't have to. It's just, the PLC is the litmus test of people who ask you a question. Have you ever programmed a PLC? And if the answer is no, they'll not look at you again. If the answer is yes, you may not have to program another PLC the rest of your life, but at least you said you would be willing to. And that's all they're asking you. Would you be willing to? People do 10%, 30%, 50%, 70%, 90% of their work programming PLCs. But that 10%, everybody has to at least say that they have done something with a PLC, because believe it or not, if they have to put you in that position, they will. And I doubt if they do very much. If that's not what you want to do. I would come back from a job when I was working, that was all I was doing. And I would put my feet up. I didn't physically put my feet up, but I mentally put my feet up on my desk for a couple of days after I got through a startup, because it just takes everything you've got. It takes a lot of effort. It's 2 or 3 weeks in a startup mode where you're going 7 days a week, 14, 16-hour days, and then it's over. And you don't have to come back and do it again for another 6 months or so. But it does take out of you a lot. And they want to know, what they're asking is, would you be willing to do something like that? And if you say no, they'll say, probably, we don't want you. What they're asking for is your devotion to the job to an extent. You don't have to be 100% devoted to it, but you have to be, at times, devoted to it. And I couldn't take programming PLCs 24/7, 7 days a week. The guy that I talk about that stood in front of the end of the line at Chrysler with the Ram trucks and was programming the last PLC in line, I wouldn't want to do. And that's not because I'm 70-some years old. I wouldn't want to do that as a 30-year-old. There's something about that the risk is just too high for me. Your tolerance level may not be that bad. But he did. He liked it. He was a graduate of electrical engineering technology at the University of Toledo. He loved the challenge of standing there, and it's like throwing the dice. You're not going to shut them down. It's 45. It was at that time. It was $45,000 a minute they would have to pay if you shut them down. What if you shut them down for an hour? That's $1 million. No amount of money in the world would I do that for. Okay, enough. What's left in this book? Not much. So we've pretty well beaten this book down, and I, for what it's worth, congratulate you on having achieved EET 1020, because you have. There's one more slight thing we got to do, and then we're done with this, and it has to do with chapter 10, which is really Bodie plots, which I tend to go into in the EET 4450 class is the class that I actually teach Bodie plots in, and that's where I camp on, and that's how I do it. And you can say, well, it's not fair because we don't know all this stuff yet. Well, you'll be fine. You'll get there. Now, this is the course EET 4450, and this is the subject Bodie, and it's under examples. I'm sorry that I don't have a full thing under here of Bodie, but it's under here. It's under examples. It's under EET 4450, and it's in Bodie. Okay. And then you say save, and then you come up here and you unzip it, and then you go and you look at Bodie plots. Okay, so it's kind of off to the side, but it's what it is. So now this is a tutorial on Bodie plots. Okay. There's the tutorial. That's what we're going to do Thursday. Here is the graph paper. Now, we used to have to send you to the bookstore to get a packet of paper, and everybody have to go and pay their $5 or whatever to get a packet of these, and that would be how you do it. Today, the wonderful world of internet gives you this stuff free. So you basically all you have to do is set it up and print it off. I will do that for you because I can. I can set this up on the printer and print 60 sheets, and you can have all that you want, and we'll have all that you want with this. But we're going to basically draw we're going to draw a response to a circuit on a Bodie plot. Okay? And you say, what is it about a Bodie plot? Well, I'm going to ask you, okay, let's just look at it a little bit closer. What does this look like to you? It's very nonlinear, isn't it? It's not like a ruler where you have lines that are equal spaced. This is a logarithmic plot. Okay? We're going to learn how to number those. We're going to learn how to keep track of how this is done. Specific set of rules for this. And it's just follow the rules, do exactly the rules, well, they say, and you'll get an answer. Okay? And then you get a response. You get a graph of it. And that's all you have to do. That response and that graph is all you need. So basically, if you feed a circuit in, you get this graph of a response, and away you go. So basically, that's all Bodie plots are, is a plot of a function. And instead of using j omega, we use something else. Get used to it. The reason I'm doing this is because our book uses j omega, and that's really not right. So our book says j omega. When you turn over to the 3250 class, they'll call this S. Okay? So instead of j omega, we'll just call it S, and we'll be friends. Okay? We'll graph it. It's just like the unknown X. We'll graph X, but instead of it, we're going to graph S, which is really the j omega. So as we say, as the frequency increases, as the S increases, we'll say as the frequency or the S increases, blah, blah, blah. That's all that is. It's the S value. So we're going to talk about, so when I come in here on Thursday, forget about j omega, forget about chapter 10, concentrate on what I'm saying to you in that little tutorial and the variable S, and you're all set. As they say, it's a piece of cake. We'll be having you drawing Bodie plots in about 20 minutes. And from that point on, you're a Bodie plot expert, and you'll have the Good Housekeeping stamp of approval for being Bodie plot experts. Okay? Doesn't take long. We'll get you there. But it's S instead of j omega, It's graphing of functions with semi-log paper, and follow these rules, get an answer, and you're done. Pretty straightforward. Not a lot of fun, but if you want to, you can bring a straight edge. Straight edges are accepted, but that's all you need, and I'll bring everything else. If you have a straight edge, if you don't have a straight edge, hold a piece of paper or just do it by freehand and until you get a straight edge. But basically, it's not a big deal. Yeah, but you got to follow the rules. The rules are very, very. You'll see. They're not hard. Just got to do them. Any question anybody's got? I'm done.